Unit 1, still on numbers, but we are going to now do part 1 of 1.2, which is on fractions. So we're moving on from the integers, the whole numbers, up to fractions. Right, let's get some words. That fraction we would read as 2/3. What we need to know is the top one is called the numerator. And for short in this lecture, I'm just going to call it and make it an N. The bottom one is the denominator, which I'm going to write as a D for short. Let's look at 3 ways of writing fractions. So you could get a proper fraction. And an example is 5/8. So in a proper fraction, the numerator is smaller than the denominator. And that means a proper fraction will always be smaller than 1 whole. Improper fraction, it's either one where the numerator is greater than the denominator, or when the numerator is equal to the denominator. So an improper fraction is greater than or equal to 1 whole. Right, another way of writing fractions is what we call a mixed fraction. It's not a mixture of proper and improper. It's a mixture of a whole number and a fraction. And we would read this as 4 and 1/3. So the and as in plus, it is not 4 times 1/3. Important here is that the fraction part in the mixed fraction must be a proper fraction. Right, one easy way of get the feeling and to understand why the rules go as they go is if we think of slicing a pizza. It just helps us to get the feeling for why do we have these funny rules. Imagine I took this pizza and I sliced it into 5 equal sized slices. All right. Five equal slices. Then each slice will be 1/5 of the whole. Right, so each slice is 1/5. If I took, for instance, 3 of these slices, okay, then it is 3 slices of size 1/5 each. So I have 3/5 of the whole pizza. I have 3/5 of the whole pizza. So, can you see what we're saying here with 3/5? The top one says, how many of these slices do I have? The bottom one says, how many slices in the whole pizza? Keep bearing in mind that we're saying all of these slices have to be the same size. Otherwise, none of this reasoning makes sense. Right. So, always remember, if I say 7/8, that means I've got 7 pieces where each one is the size where I have cut the whole thing into 8. Can you see from this that if the denominator is large, that means I've cut the pizza into lots of slices. Then each slice is small. Okay, let's have a look at, let's imagine I've now eaten these 3 slices and now I have left 2/5 of the whole pizza. But I need to share it amongst 4 people. Well, plain logic will tell me, what would I do? I would cut each slice exactly in half. So now, after I've cut that, I have 4 slices, but remember, each slice is now smaller. So it's not like I suddenly have more pizza. Each slice is now smaller. So what I have now is 4/10. How do I know it's tenths? Well, if you looked at the whole one and you cut it all through, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each person now just gets 1/10 of the pizza. Right. So what are we saying? We're saying that 2/5 is exactly the same as 4/10. I don't suddenly have more pizza. I have 4 slices, but they are smaller. If we just look at the numbers and we forget about the pizza, can you see that I had to times the 2 by 2 to get 4? And I had to times the 5 by 2 to get 10. So if we go back to the 2/5 and we times the 2 by 3, I will get a 6. And a 5 times 3 will give me a 30. Right? So there are different forms. They are called equivalent fractions because they mean the same thing. It just means you cut your slices into smaller slices, but it still is the same amount of pizza. Last thing I'm going to say, this form is the simplest form of them all. You can't break this one into any smaller sizes now.